Hello, today we are going to be reviewing your exponent, scientific notation, and squares and square roots study guide. So the first part here says to simplify the expression, write your answer using only positive exponents. So the first thing that we always need to do here is see what we can simplify first before we start dealing with the negative exponents and our zero exponents. So whenever you guys see same bases, we can definitely simplify. So this is product of powers. First, see if you have any coefficients. So those are numbers attached to variables. Because if we did have coefficients, you would just multiply those like normal. But in this case, we do not. Then whenever your base is, so in this case our base is v, the base is going to stay in your answer. And then the rule is you just add your exponents. So 3 plus 6 gives us 9. So our answer here is v to the 9th power. Okay, our next one is quotient of powers. So again, the first thing that you want to look for is your bases to see if you can simplify, which in this case we can. Always look for coefficients first. So in this case, we do not have any numbers attached to variables, so we would not divide like normal. So then you move on to your base. Our base is 6, so 6 is going to stay in our answer. And then the rule for quotient of powers is you are going to subtract your exponents. So 8 minus 2 will give you that 6. So product of powers, you're adding your exponents. Quotient of powers, you're subtracting your exponents. So number 3, here's another product of powers, and this time though we do have coefficients. So again, if you have coefficients, you're just going to multiply your numbers like normal. So 4 times 5 gives us 20. Look at what your base is. So our bases are u, so u stays in your answer. And then again, just like number 1, the rule for product of powers is you add your exponents. So 3 plus 12 gives you a positive 15. Number 4, notice how there's nothing really to simplify because you don't have same bases. The only thing that we need to look at is this a to the 0 power, because remember guys, anything to the 0 power is 1. So technically this is just 1 because a to the 0 power, anything to the 0 power is 1. So technically it's just 1 times b to the 15th, which 1 times anything is just that anything. So our answer is just that b to the 15th. All right, next one is a power to a power. So always check the inside of your parentheses first to see if we can simplify anything. So we don't have any bases that are the same, so there's nothing to simplify. So the rule is when you have a power to a power, you're just multiplying your exponents. The only thing that students mess up all the time is that they only want to take the 5 times the 3. But do not forget that coefficients also have that imaginary 1 exponent. So this 5 also needs to come over to this 5 over here as well. So everything that's inside is going to stay the same. So your coefficient is going to stay 5 for now. And then your base of c is going to stay. And then the only thing that's changing are your exponents. And again, power to a power, you're just multiplying. So this power of 1 on the 5 is going to be changed to a 5 times 1, which is 5. And then your c, your base c, had an exponent of 3, and then it's going to be changed into 15 because 3 times 5 is 15. So power to a power, you're multiplying. And again, don't forget that coefficients do have that imaginary exponent as well, and that outside power is going to go to every single thing on the inside of that parentheses. All right, number 6. So really, first thing you always are looking for are same bases. So I have a base n and a base p, so there's really nothing to simplify. So really the only thing that they want us to do is to change this negative exponent into a positive. So the way that I taught it in my class is a negative exponent is an unhappy exponent. And if they are upstairs, you move them downstairs and they become happy. If they're downstairs, you move them upstairs and they become happy. So since P is not happy right now and it's downstairs, to make it positive, or in other words, to make it happy, you just move it upstairs and then it becomes happy. And notice how the 12n squared is happy upstairs. So you're just going to move that piece to the -2 upstairs, and then just put all of it together. And that is your answer. All right, number 7. So when I have parentheses shoved up next to each other, that means that they're multiplying. So this goes back to our product of powers. Before I multiply, though, I see a b to the 0 power, and as we know, anything to the 0 power is just 1. So technically this is just going to cancel out. So really I'm just taking a to the 8th b squared times a, and don't forget that there is an imaginary 1 here, okay? And the thing to remember about when you're multiplying with same bases is you can only combine exponents together if they have the same base. So once I crossed out that b, I only have one base of b left. So that means that I'm still going to have that b squared in my answer because now there's nothing to combine it with. Our a's on the other hand, so I do have a base a. And then again, the rule is you just add your exponents. So since I have two base a's, I'm going to combine these together and then just add the exponents. So 8 plus 1 gives us 9. And that's your answer. Even if you were to keep the b to the 0 power, you would still get this b squared, because if you were to combine your b's, you would keep your base b and then again just add your exponents. So 2 plus 0 would just leave you with that 2. All right, and then last one here, number 8. So r to the 7th over u to the 6th. I don't have same bases, so I can't combine those. All that they want me to do is to take it to the power of 2. So remember, a power to a power means that this outside exponent is going to be multiplied to every single exponent on the inside of that parentheses. So your bases are going to stay, so r and u are going to stay, but our exponents are just going to be changed to 7 times 2, which is 14, so it's now going to be r to the 14th, and 6 times 2, which is 12, so it's going to be changed to u to the 12th. All right, so moving on. Number 9, in 2013, the Los Angeles Dodgers opening day payroll was about 2.16 times 10 to the 8th, and the Houston Astros opening day payroll was about 2.4 times 10 to the 7th. How much higher was the Dodgers payroll? So first thing we need to do is figure out what operation we're doing. So if we're trying to figure out how much higher the Dodgers payroll was compared to the Houston Astros, that operation means is we are subtracting. So we are going to start with the Dodgers payroll, which was 2.16 times 10 to the 8th. And we are going to take that minus the Astros payroll, which was 2.4 times 10 to the 7th. So this is scientific notation with subtracting. So remember, whenever you guys are adding or subtracting in scientific notation, you have to have same base to the same power. So you have to have either both of these to be 10 to the 8th or 10 to the 7th. And it's a lot easier if you always change your smaller exponent into the larger one. So we're going to keep this 10 to the 8th over here, which means that our constant of the 2.16 is going to stay there. But over here, as soon as you change this 10 to the 7th to match the 10 to the 8th, you have to ask yourself how many times greater did you what did you add to get from 7 to 8? Well, we only added 1. So if you're adding 1 to your exponent, that means you're making this number larger by 1. So you need to account for that by making it smaller by 1. So to make 2.4 smaller, you just move your decimal point back 1 space since you only added 1, so you're only going to move the decimal 1 time, and that will leave you with a 0.24. So your number should always stay the same. Like this number, 2.4 times 10 to the 7th, still equals 0.24 times 10 to the 8th. Okay, so we're not changing the number at all. It's just since we added 1 to our exponent, we need to account for that by making this number smaller by 1. Okay, so now that we have same base to the same power, we can now just subtract these like normal. So just subtract your constant. So 2.16 minus 8.24 is a 1.92. And again, we're talking about money here. And then the reason why you had to get same base to the same power is because that is going to stay in your answer. So your answer here is 1.92 times 10 to the 8th. All right, number 10, a TV show had 3.5 times 10 to the 6th viewers for their first episode and 8.5 times 10 to the 6th viewers for their second episode. How many viewers do they have overall? So again, you need to decide what operation we're doing here. So in this case, we will be adding these two together since we're trying to figure out overall how many viewers we had. So we're going to take this 3.5 times 10 to the 6th plus 8.5 times 10 to the 6th. Now the nice thing about this one is, remember up here I said whenever you're adding or subtracting in scientific notation, you have to have same base to the same power. And notice how we have already given you guys same base to the same power. So there's no moving of decimals quite yet. Okay, so we're just going to add like normal. So add your constants. So 3.5 plus an 8.5 gives us a 12. And then you keep your same base to the same power. Now this is not our final answer though, because remember your constant always has to be a number between 1 and less than 10. So 12 is greater than 10, so this is technically not in scientific notation yet. So to make it into scientific notation, remember that there's a decimal after every single whole number. So to make 12 into a number that's between 1 and 10, if you just move your decimal point 1 time to the left, you would now get 1.2, which is now a number between 1 and 10. And then if you are making this number smaller by moving it 1 time to the left, you have to account for that by making your exponent larger by 1, since you only moved your decimal 1 time to the left. So just add 1 to your 6 and you would get 10 to the 7th. All right, number 11, how many times larger is 13,500 compared to 1.5 times 10 to the 3rd? Write your answer in standard form. So these two forms are not the same, and whenever you guys are doing these, you always want to make sure you're either in scientific notation for both of them or standard form for both of them. And since they want our answer in standard form, I'm going to put both of these answers in standard form to start. So we have 13,500, that's in standard form. And then this 1.5 times 10 to the 3rd. This exponent tells you how many times to move your decimal point. So it's telling me that I need to move this decimal point 3 times. Since it's a positive exponent, that means I'm making this number bigger. So if I need to make this number bigger, I'm going to move it to the right. So there's 1, 2, and 3. And then all of your empty spaces would just be filled in with zeros. So 1.5 times 10 to the 3rd is the same thing as 1,500. So now that both my answers are in standard form, I'm now going to figure out how many times larger is this number compared to this number, which means that we're just dividing. So I'm going to take 13,500 divided by 1,500, and if you were to plug that in your calculator, you would get 9 times bigger. All right, and then the last one here, so an airplane traveled 5.7 times 10 to the second miles per hour for 1.4 times 10 to the first hours. How far did the airplane travel? Write your answer in scientific notation. All right, so again, the operation that we're doing is we're going to be multiplying here because they travel for this many miles for this many hours. So to figure out that miles per hour, you're going to multiply. So we're going to take 5.7 times 10 to the second. All that times our 1.4 times 10 to the first. Now, whenever you are multiplying or dividing with scientific notation, you do not have to have same base to the same power because we have exponent rules that tell us what to do with them, okay? So, when you're multiplying, you're just going to multiply your constants like normal. So, if you were to take 5.7 times a 1.4, you would just get a 7.98. And then following our exponent law rules, you keep your base of 10, and then when you're multiplying same bases, all that you do is you add your exponents. So 2 plus 1 would give you 3. So the airplane traveled 7.98 times 10 to the third miles. All right, moving on to our back side. So when the moon is between the earth and the sun, the distance from earth to its moon, so we have a diagram here, so the distance from earth to its moon is 2.389 times 10 to the 5th. From the earth's moon to the sun, so this distance is 9.3 times 10 to the 7th miles. Find the distance between the earth and the sun and write your answer in scientific notation. So if we tell you guys this distance from the sun and the moon, and then we tell you guys this distance from the moon and the earth, and we're trying to figure out the whole distance from the earth to the sun, the operation that we're doing here is we are going to add these two scientific notations together. So we're going to take 9.3 times 10 to the 7th plus a 2.389 times 10 to the 5th. So remember, when you're adding scientific notation, you have to have same base to the same power, and you always want to change your smaller exponent into the larger one. So I want to change both of these to 10 to the 7th. So since this base is not changing, our constant of our 9.3 is going to stay. This number, though, however, if we change our exponent from 5 to 7, that means I'm increasing my exponent by 2, so I need to account for that by making this number smaller by 2. So I'm going to move it 2 times to the left, and I'm going to fill in a 0 into that empty spot. So this number is now 0.02389. Okay, so as soon as you have same base to the same power, you're now just going to add your constants like normal. So we're going to take a 9.3 plus 8.02389, and that gives me 9.32389. And then you keep your same base to the same power. So our answer is 9.32389 times 10 to the 7th. All right, number 14, select all the expressions that are equivalent to x to the third times x to the negative fifth. So product of powers, you keep your base, so our base is going to stay x, and then remember you just add your exponents. So 3 plus a negative 5 gives us a negative 2. So we are looking for everything that is equivalent to x to the negative second power. So the first one that I see here is A, because that matches what we got. And then remember, our other thing is we can make this into a positive exponent, because if it's not happy upstairs right now, you can take it downstairs and then it becomes happy. So x to the negative second is equivalent to 1 over x squared, which also matches C. So your only two expressions that are equivalent is A and C. Number 15, fill in a number to make the statement true. So again, product of powers, you're keeping your base, and then you would just add your exponents to get your new exponent. So if we have a 4 here and we have a 10 here, just take your 10 minus 4 to figure out what this exponent is going to be, and that means that your exponent is going to be 6. On our number line here, I'm going to label these A, B, C, D just to make it easier. So the square root of 20, there's a couple different ways that we can think about this. One way is just plugging it in your calculator, and you would get approximately about a 4.5. Another way that I taught in class is if you were to approximate by thinking that 4 is the same thing as the square root of 16 and 5 is the same thing as the square root of 25. 20 would fall pretty much right in between that 16, the square root of 16 and the square root of 25. So that's another way that you guys can approximate it. So here's A. B is pi, so remember pi is equivalent to 3.14, so it's going to be right next to that 3 on the right side. C here is about 2.3, so you go over 2 and almost halfway but not quite, so there's C. And then D is a negative square root of 5. So again, if you're approximating, you can think about our negatives, how square root of 5 is going to fall in between the square root of 4 and the square root of 9, pretty close to the square root of 4, or if you were to plug it in your calculator, taking a negative square root of 5, you would get that negative 2.2. All right, so this is how your guys' number line should look like. Next one is another number line, so we are trying to figure out which of the following is closest to the point F. So if we were to take the square root of 7, square root of 7 would be right in between 2 and 3, so that's represented by the point E. So we'll try to put E here to remember that. 1 and 5/7, that's just a little bit to the right of 1, but not quite to 2, so that is not closer to F than A was, so I'm going to cancel that out. Square root of 15 is going to fall in between 9 and 16 and a little bit closer to 16, so that is closer than E. So I'm going to write F there for now, and then let's just double check this one. So 35%, if you guys were to plot this, you would have to change it to its decimal form. So 35% as a decimal is 0.35, so that would be somewhere way over here. So the closest number to F would be the square root of 15. All right, number 18, estimate the value of 3 to the square root of 10 to its nearest integer. So remember, guys, a number outside of your square root just means that you're multiplying these two things. Some calculators, you'll be able to type it in just how we have it. Others, you might have to do the square root of 10 first and then multiply it times 3. But either way, you get about 9.48, or in other words, 9.5. So if we round that to the nearest integers, 9.4, you would round it down to just 9. All right, and then fill in the blank. So we're trying to figure out what operation needs to go in between here. So again, a number outside square root means you're multiplying. So if you were to take 2 times the square root of 15, you would get about 7.7. 3 times the square root of 6, you would get about 7.3. So this number is larger than this number, so you would want the greater than sign. All right, number 20, how many square roots does 49 have? So the main thing to remember is that when you are solving and taking the square root of a number, please remember you don't just get the positive number anymore, you also get the negative, because 7 times 7 is 49 and negative 7 times negative 7 is 49. So the answer that we're looking here is how many square roots does 49 have? You would say 2 square roots and then it says explain. So 2 square roots because, and then you just write 7 times 7 equals 49, and -7 times -7 equals 49. And that's your answer. 21, between which two whole numbers is the square root of 40 located on the number line? So you can, again, use your calculator to figure out what two numbers would fall in between the square root of 40, or you can use the trick that I taught in class. So you can change all of your numbers to their square roots. So if you look at 6 times 6 is 36, so that would be the square root of 36. 7 times 7 is 49, so that would be the square root of 49. And 40 would fall right in between those two perfect square roots. So it would fall in between our numbers of 6 and 7. All right, number 22, select all of the following solutions to the equation. So again, whenever you are solving a square root problem, the opposite of squaring a number is square rooting to get x by itself. And when you take the square root of 63, remember you get two answers. You get the positive and you get the negative. So in our calculator, we're going to take the square root of 63, and we give about 7.9. So if we were to round that to the nearest integer, because that's what it tells us to do, we would round it up to about 8. So we would get positive 8 and we would get negative 8. All right, so we're going to do that same thing for our last 3 problems. So again, to solve this equation, you have to get rid of that squared. So the opposite of squaring something is square rooting. And remember, when you are solving and you're taking the square root, you get the positive and the negative answer. So the square root of 81 is going to give us that positive -9, because 9 times 9 is 81. Number 24, same thing. This time we're just rounding to the nearest tenths. So again, opposite of squaring something is square rooting to get x by itself. So if we were to take the square root of 243 in our calculator, we get about 15.58. So rounding to the nearest tenths, look at your tenths place, look at the number behind it. If it's 5 or greater, we're going to round this up 1. So since 8 is 5 or greater, rounding this number to the nearest tenths would be plus minus our 15.6. All right, and then last one, we're going to round to the nearest integer. Same thing, opposite of squaring is square rooting. So we're going to get x equals plus minus, and then the square root of 80 is about 8.9. So rounding it to the nearest whole number would give us positive -9. And that is it. So if you guys have any questions, let your teacher know.